Finally, a bystander is watching an eagle fly at a height of 200 meters and at a speed of 30 meters per second carrying a rock. So above the ground by 200 meters, and the eagle is flying along at 30 meters per second. The eagle lets go of its rock, and we're going to allow ourselves to ignore air resistance. What will be the speed of the rock when it hits the ground from the eagle's reference frame? Well, this is really simple. This is just a classic, how fast does the thing fall? Because from the eagle's frame of reference, the rock isn't moving horizontally. The rock is moving along with it. While the eagle is moving, the rock is also moving that much horizontally. So all we care about from the eagle's frame of reference is acceleration down. So we've got just gravity to deal with in this case. So how do we figure that out? Well, we know that V initial, we're going to be looking at everything from the y-axis point of view, because from the x-axis point of view in the eagle frame, remember this is all about the eagle's frame of reference, eagle reference frame is what we're all doing all of our work in. So we're only going to be looking at the y-axis. So the V initial is equal to 0 because at first it's not going anywhere, it's just going along with the eagle at its current speed. The eagle lets go. We don't know what V final is, that's what we're going to look for. We know what acceleration is equal to g, which is equal to 9.8 meters per second. And finally, the distance is equal to 200 meters that it falls. Well, we've got this great formula. Vf squared equals Vi squared plus 2 times A times D equals 0 plus 2 times 9.8 times 200. We punch that into our calculator, and we get that that's 3920. We take the square root of that, and that gives us that the speed is going to be equal to 62.6 meters per second. And that tells us what speed the rock is moving at the instant it hits the ground. So we know that the rock from the eagle is moving at 62.6, and if we were going to put a sign on this, we'd say negative 62.6, but we also just know, since we've got this arrow right here, that it's moving down, so it's up to us as the physicists to pay attention to what we're doing with our work here. 62.6 meters per second is its instantaneous velocity at the moment of impact. So now we want to see, what does the bystander see? Well, the bystander is going to see both of them combined. He's going to have the speed of not just, because from the eagle's point of view, he was moving and the rock was moving. But from the bystander's point of view, he's not moving while the rock is moving. So we've got the rock moving at 30 meters per second. Once again, we've got that height of 200 meters. So now, how do we figure that out? Well, we want to find out if we've got a velocity of, the velocity of the rock moving at 30 meters per second, and we know that when it lands, it's going to hit with 62.6 meters per second. We'll notice that in these two different reference frames, the eagle and the human, they both have no difference. There's no y difference. So eagle versus human, no y velocity relative. They're not moving in terms of height. The eagle is flying along parallel to the ground. So if the eagle is flying along parallel and he drops the rock, then the rock is only going to be accelerated vertically. So the human doesn't see any horizontal change. The horizontal velocity is going to remain the same until something else acts on the rock, which will be the ground. So as long as it hasn't touched the ground, or just as it touches the ground, it's going to still have the same velocity that it initially had. So from the human's point of view, we're going to see the velocity final. We don't even have to do any math for this because we can do this all by reasoning. Is going to be, what's the y? Well, the y will be 30 meters per second because it hasn't had any change to it. There's no horizontal acceleration. The only thing acting on the rock is gravity, so 30 meters per second. And we know from the eagle's reference frame that when it hits the ground, it's going at 62.6 meters per second down into the ground. So 62.6 meters per second. Now, since we're in component, we got to have a negative sign. And that's what the human sees, is he sees the same speed as before, But now, in addition, it's got this horizontal component to it, because there's no difference in the acceleration that the two things are seeing, because the only relative difference that they have is this horizontal thing. Finally, what's the acceleration for, human versus eagle? Well, they're both going to have the exact same thing, because the velocity of A to B is equal to just the 30 meters per second, comma 0, and it doesn't change. It stays the same throughout, so that means our acceleration here is nothing. There's absolutely no relative acceleration, so the only thing that they're seeing is they're going to see the exact same acceleration in both cases, which is just gravity. So that gives us an idea of what reference frames are. I'm glad you saw Educator.com, and we'll see you next time.